Hello, everybody. We're going to get started. Talkers in the back, in or out? Oh, I was talking to them, but. All right, we're an intimate little group here, so if you have questions as I'm talking, feel free to just shout them out at me the same way you did last time. What we're going to be talking about today is Composable Data Platform. If you were not at my talk yesterday, this is a new data access product that SDF has developed. And today, what I'm going to be kind of demoing is how easy it is to use, because it sounds a little intimidating. It's a couple big words in there. You don't really know what it means. But to frame why we did this, I'm actually going to start out with a little video. This was a big meme video that was big with backend engineers 5-10 years ago. So if you've never seen this, oh, there it is. If you've never seen this, you're welcome. But it'll be about 3 minutes.
Just one feature. Why is it taking 3 years to roll out? Look, it's not that simple, all right? I have priorities, my team has deadlines, we have other deliverables in progress.
I'm still not understanding this. Why is it so hard to display the birthday date on the settings page? Why can't we get this done this quarter?
Look, I'm sorry, we've been over this. It's the design of our back end. First we have to build a bingo service. See, bingo knows everyone's Memo, so we get the user's ID out of there. Then from bingo, we can call Papaya and MBS to get that user ID and turn it into a user session token. We can validate those with Omnop, and then, once we have that, we can finally pull the user's info down from Raccoon.
Yeah, but couldn't the Raccoon team basically just...
No, Raccoon isn't guaranteed to have that info. Before we do this, we have to go to Wingman, do a query to see if the user's willing to take it to the next level, or if they're just playing the field. Now, Wingman is cool, but he doesn't store any user info himself. He has to reach out to other user info provider services, like RGS, Barbie Doll, Ringo2, BLS. But how does it know what all the user provider services are? Well, for that, it has to go to Galactus, all-knowing user service provider aggregator. And while Galactus has omniscient knowledge of all current user info providers, it doesn't have future sight or knowledge of past user info providers, so it expects a time range. To get all the current user info providers, we need to pass a time range with the current time and a time representing the end of the universe, which we get from EKS, our entropy chaos service. EKS is being deprecated at the end of the month for Omegastar, but Omegastar still doesn't support ISO timestamps like they said they would a month ago, so until Omegastar gets their fucking shit together, we're blocked. We can't get signed up for our use case, we can't use EKS, there's nothing we can do. So Galactus won't be able to find our new birthday boy provider, which means Wingman won't know how to talk to anybody, which means I won't be able to find true love and I'll die alone. I'll die alone, without ever knowing love, without ever knowing it's my birthday. We're blocked, okay? We're blocked, you sad, pathetic little product manager. You think you know what our users want? You know nothing of my pain, of Galactus's pain. You think you know what it takes to tell the user it's their birthday? You know nothing. Delivering this feature goes against everything I know to be right and true, and I will sooner lay you into this barren earth than entertain your folly for a moment longer.
All right, so clearly this is Blocker. No problem, we'll push this out another 2 to 3 years or so. Learned a lot today, love Galactus. But we'll talk next week about adding middle names to the profile. Awesome, sounds good. Take care.
All right, why did I show you that? If you've been a backend engineer in industry, you can maybe relate to this a little bit. Or if you've just worked with a product manager, here's my product manager. Common dynamic. Now, Horizon is not a set of microservices. It is a monolith. But it has a very similar dynamic to this in that we very often get from product or from the ecosystem or from whoever, very, very simple feature requests, or requests that sound incredibly simple. And it's my product manager, John, who'll ask me to do them, and I'll say, we're not going to do this, or it'll take 2 months, right? Why is that? So we're going to talk a little bit about why that is through an example, before we then show you how incredibly easy this same thing would be to do with CDP and a custom ingestion engine. So the request, or what we're going to talk through, is actually a real issue. This is a GitHub issue that was filed, I think about 3 weeks ago, last month, by Alien 2108. Don't know who that is. He's probably not here because it's a very small crowd, but I'm sure he doesn't know we're talking about him. What he's asking here, right, is get memo with payments function and avoid unnecessary transactions call to get memo. So you may, if you're not familiar with Horizon, we're going to do a little preamble to explain what exactly he's asking. But in essence, it sounds like he's basically asking for a single field to be added to an API, the memo field to be added to the payments API. Sounds like sounds like adding your username or your whatever they were saying, birthday to user profile, right? It's nothing. It's nothing. Well, it turns out. Well, actually, let's talk about what a memo is. So I can look at this one. I don't know why I'm looking at the screen. So a memo, if you're not familiar, is really just an unstructured text field. It's defined in the protocol. This is the page on it from our developer docs. There's actually a second kind of companion field to it called memo type. So you can see here, it can be one of 4 types. That's an enum, and that just tells you how you can parse the memo, basically. It's just an unstructured text field. That's literally it. It's currently returned, you can see here, by Horizon transactions endpoint because it's a field defined at the transaction layer. If you don't know, right, transactions, kind of the higher level data structure, and there's operations within a transaction, right? All operations within a transaction are atomic, right? So there's kind of like a parent-child relationship here. You can also see the entire history, all the memos that have ever existed in Hubble. Hubble is our analytics data set. So you can see how people are using these. They're using them in a lot of random ways. Sometimes there's just garbage in there. Sometimes bots throw information in there, seemingly to try and do some shady stuff. But one of the meaningful ways that these are used is actually by exchanges, centralized exchanges that use omnibus account structures. So this is a screenshot from Stellar Expert, but it's showing a Coinbase, one of Coinbase's deposit accounts, so they're incoming deposit accounts. And you can see here it's displaying a memo of some integer value. This is actually the user's account in Coinbase, right? So Coinbase is using it in an actual kind of legit way to identify within their giant omnibus account which user this is actually related to. It's kind of a scary way to use, like a legit way to use a unstructured text field. So this is questionable behavior in general, but just know that is actually how it is used now in very legit ways. So it's a pretty reasonable request to ask for this field to be available on a payments API, right? Well, let's talk a little bit about how Horizon implements payments. So if you're not familiar with Horizon, these are kind of, it has a lot more endpoints than this, but these are kind of showing the big high-level ones that map directly to data structures. Horizon stores basically these transactions, ledgers, operations table. These are all giant, immutable, kind of append-only tables. So full history of all transactions, full history of all the ledgers, full history of all the operations. Now, notably, the payments API is served actually from the operations table. So there's no payments data model that is actually stored in a database in Horizon. Why is that? I'm not sure. I wasn't here when we made that decision, but payments is a derived kind of API or derived data model, right? Really all it is a filter on top of those operations. This is kind of unique to Stellar and most other chains. there's one way to make a payment or there's one way to transfer value. In Stellar, there's a bunch of different ways. So it's actually kind of hard as a user to understand how those all happen. You can see a list here. But if you create an account, that moves money. If you merge accounts, that moves money. If you do a path payment strict send or receive, that moves money, right? This one at the bottom, ignore it for now, but it's for the invoke host function operation, which is Sorbon. So not all Sorbon operations are payments. Some of them are not. So that's why we have this new little fun one at the bottom that can't be derived by operation type. But the point is, right, all payments is in Horizon is a filter on top of operations. So it's not saved on its own. So let's think for a sec about how we would add a memo field to the payments API if it's not saved on the operations table, right? Going back to kind of system design, first principles, we're going to talk through kind of two general approaches, right? Fan in or fan out and fan in, right? So when I say fan out, generally means kind of like denormalize the data, right? Like shove it out there on the right. So in this case, that would mean we could this is an option for how we could do this. We could denormalize the memo field onto the operations table on ingest. So that means when a ledger closes, Horizon takes it in the right path, it writes the memo field on the operations table, pulls it from the transaction. It has that data. It can totally do that, right? This is an option. But number one, or a bunch of reasons why it's not great. It has the potential to slow down ingestion. And ingestion is kind of one of our like danger metrics, so to speak. And by that I mean, unlike other chains like, I'll call it out, because Solana, for example, right? They don't really care if you can ingest within the ledger close time, right? You're kind of good luck if you can try to do it. We don't really take that approach, right? We always want ingestion to be lower than the ledger close time. Our ledger close time right now is like 5 to 6 seconds. And our ingestion time right now is 1 second, right? But we're constantly trying to lower it. The reason for that is, right, you never want it to be higher than the ledger close time, because then you will just continually always be coming further and further behind, and you'll never be up. You'll never be current with the latest ledger. So that's a risk, right? If we were going to do this, we would benchmark it internally on all different kinds of database constructions, database retention sizes, and we would make sure that it's not going to cause any regressions there. So that's a lot of work. That's a fair amount of work. But the more annoying part is that it will require a data migration. So of course it will require a schema migration, right, to add the memo field. It'll also require us to add data to that memo field, right? And that may sound fine. We can discuss kind of all the ways that we could do that, but keep in mind, as we talk through all these, that Horizon is, again, an open source tool that's run by many different operators across the ecosystem. So we don't actually have control over when they update their data, when they migrate their data. We don't know how they're doing it. We don't know if they're doing it in a safe way, offline, or in line with the live application, right? And we've actually seen that they do this. People, I won't name names, but some companies that you'd think are should be very with it are not. So this is a problem. A couple of ways that we could migrate data, right, are synchronously with the schema migration, meaning new update rolls out, your service, Horizon, is down while that data migrates, right? Meaning, sorry, let me back up. Data migrating meaning I need something to query the transactions table and then write all the memos from the transaction table into all the operations, right? If you're running a full history Horizon database that is 40 terabytes, this could potentially not only take hours, like this could take days to run, right? So that could mean that your database, you try to update and it is down for many hours or a day. hopefully you're running redundant clusters, but you might not be, right? We can't actually know how people are running it. So that's not great. That's not really an option. We want to do zero downtime migrations when we can. So another option is asynchronously in a prior deploy. If you've done backend engineering at any kind of enterprise company that's not open source, this is just kind of, by this I mean your kind of standard data migration model. So I deploy one version of my service that just adds the column, and then it writes to it in the back. I deploy an asynchronous job that maybe writes to it in the background, and then I deploy my application code that reads from the new field, right? And then I drop the old column, right? You're kind of like safe series of deploys. But you need multiple deploys to do that, right? That's how you would typically do it. Again, because we're open source, because we have other operators running it, we can't necessarily ensure, right, that everybody's going to deploy and run it in that way, right? Some people may skip entire versions, and they often do, right? In which case, that kind of is out the window. Another option would be to migrate on read. So this is another very common scheme in generalized kind of backend engineering where I don't migrate the data at all, but the first time somebody tries to read that one, I migrate it then, right? So you effectively pay a cost for the first time you try to read that migrated data, but then every other time it's fine because it's there, right? This is okay. This is maybe an option, right? You could do that inline or you could do it asynchronously. But that's going to have some, immediate cost for your service, right? You're going to see a huge kind of like spike in potentially resource usage that hopefully you're able to handle, right? But you'd need to simulate that. We'd need to benchmark it were we to do this. We don't do this now. Or you could not migrate the data at all. This is always an option, kind of. In that case, you just completely throw the responsibility for dealing with this to the end user. By that I mean somebody that's using Horizon, querying Horizon, they now need to know, hey, the memo field was added to operations sometime around October 17th, right? So if it's before that, if this transaction is before that, I'm going to query transactions. If this transaction is after that, I'm going to query, I'm going to not worry about it. That's a little crazy. It's an option, right? It's an option in that it's good for the service, no resource contention, but I don't think our product managers would be cool with that option. It's not great. So this is not a great option, right? Migrations in general on a project like Horizon are extremely hard to do, which is why we don't do them or we avoid doing them wherever possible unless there's a extremely good reason. As an example, we recently did a bunch of performance improvements related to the truncation. And some of those we opted not to do because they involved creating indices, which took 8 hours to complete, 8 hours to create, right? That's not worth it from a kind of this like kind of, balancing what the user needs, what the operator needs, and what we ultimately want to do. So we try to avoid data migrations, if at all possible. The other option, if we didn't want to do this kind of fan out or write option, is to fan in. And by that I mean, in this case, we could join the transactions with the operations in the actual database query. Reasonable, right? Probably, well, we'll talk about it, because there's another option in fan in, and that is to make an additional network call. You query transaction or query operations. The application code of Horizon does the same thing it always did, right? Queries operations, and then it makes a second query to basically bring. So basically, you're doing the join, same join, in application code. Again, kind of back-end engineering first principles. Usually, the second option, you may be like, why would you ever do the second option? Because network calls are generally the most expensive thing we do. So naively, you could say that's obviously going to be worse. with a 40 terabyte database, all bets are off. So this is another thing where we have seen it not follow the kind of normal pattern when we've tried to benchmark such things. So all that is to say, right, forget everything you previously knew about, or the very kind of naive first principles of what you would prefer. So the obvious detriment to this is that it significantly slows down API requests. Joining transactions with operations, close to 92%, I just looked this up earlier today, close to 92% of people that query the operations API just ask for the maximum amount they can possibly get. So they ask for 200 operations at a time. So that would mean joining, a lot of data on disk in that join. It's going to drastically probably hurt the performance of this API. And notably, all the users of the operations API now pay the price for this one use case, right? Meaning, I think this is a decent idea to get the memo on the payments API, but I don't know if just Alien 2108 wants it or everybody wants it, right? And if there's people out there that don't want it, and now their API is 2 times as slow or 3 times as slow or even a little bit more slow, that doesn't seem fair either, right? Or that's a worse experience for them, right? So not great there. And then, of course, increased server and database load forever, right, on all queries that this does, even for users that don't want it. And the worst of which, we would have to benchmark this, and it may require additional indices to fix those performance issues, right? I'm not going to retype all the things on the prior slide, but to add an index is a database migration, right? So we have all the problems of the prior slide again, right? So I hope I've convinced you here that it's hard. Maybe John's my product manager, right? This is why it takes us months potentially to do very simple things. Hopefully that has sunk in. So let's go back to the issue, right? And we're now going to talk basically about how we could do this. If you're Alien 2108, I have said everything I just said to you. I can't really write that on a GitHub issue, but I've said everything I've just said. I've explained why we're not going to do it in Horizon, but you still want it. And you can actually get it yourself quite easily. Just showing you this diagram again. This is something I showed yesterday at my kind of broader talk on CDP. But what we're going to do now in this session is basically pick out the yellow components are the actual components of CDP. So it's not complicated at all. It's literally a service and like a couple libraries. When we say CDP, we mean a single service and a couple libraries that you can kind of use in whatever way you want to get whatever data you want. Ooh, I just messed up my microphone wire. I think it's cool. So we're going to run this, and we're going to write the BYO application that's using these things. And all it's going to do is basically get the memo data. I have a video of my kind of screen grab, because I was advised yesterday not to do live coding, but I'm going to do it live. I'm going to not do the coding live. I'll do the demo live, and if the demo gods are against us, we'll go back to the video. But I think we'll be fine, because it's extremely easy. So the first, is big enough? Yeah, it's big enough, right? All right, so first thing we're going to do is we're going to run Galaxy, right? Galaxy is a service that all it does is wrap captive core and push data to GCS. Oh man, I got 30 minutes. Okay. Shouldn't talk so much, guys. Now, hopefully this loads. All right. So I have a demo project here in GCS. And this is actually the bucket that I created when I was doing the actual, or the, whatchamacallit, the recording of my demo last night, but for illustrative purposes, we're going to create a new one that we export to. So you guys can see I'm not actually lying. So all you need to get here is basically create a GCP account and to set up billing. In my case, I roll up to the SDF organization, so I did not set up billing, but all I did was create a empty project. And I'm going to need to create a bucket to store all my ledger data. I'm going to call it ledgers. I'm going to connect to testnet. You are right. That's a sub bucket. So I'm going to choose the lowest latency. If you have strong feelings about any of this, none of it is going to affect the use case of Galaxy, even this. So we have a kind of public access prevention. You may think, hey, I'm going to have to read from this bucket. You're going to use auth credentials, right? So it doesn't matter. If you care about the deletion policy, change it. None of these settings make any difference at all as to how CDP is going to utilize the bucket. I'm going to create some folders in here just because this is kind of GCP, or GCS rather, best practice. Oh, I already have a testnet one in there. That's weird. Oh. That's a little weird. I don't know if you saw I typed in the bucket name. I wonder if it like sudo created it, but you did see it error. So hopefully we got live demo gods working with us. But anyway, this is a empty bucket right now, nothing in it. Here we got Galaxy. I think I should already have the latest version of the Docker image. That's not how you spell Galaxy. Got the latest version of the Docker image, 1.0. It's been run 2 months ago. I'm going to run this. Oh, actually, first I'm going to show you the config. We can see this as well. So a couple things. Oh, my screen is very dark with that light. A couple things to note in here. We have configuration for what data store you're going to use. So a big kind of pitch of CDP is that you can actually plug and play in whatever data store you want here, and that interface, right, is kind of handled for you. Now we only actually have GCS support just because that's kind of the MVP that we built, because our internal product Hubble is deployed in GCP, and so it was kind of the easiest, or the one that benefited us the most. But we would love open source contributions for different backends. We will probably build ones for common ones that you want, S3, R2, maybe a local file system, maybe like an MQTT or some kind of queuing backend, right? But point is, you can't configure anything else other than GCS for type right now, but all the infrastructure, all kind of the code around it is there. So this is the bucket name that I just created, Meridian Demos Ledgers. Is it plural over there too? It is. Okay, so we're okay. So that's literally all that I need to configure. There's some other options you can do here. You can upload multiple ledgers per file. For the most real-time data, you probably want to use one. Partitioning structure, I'll show you what that looks like as Galaxy starts uploading. And then you can just select your network. So this config also sets basically everything related to the network for you, like the network passphrase, the history archive URLs, anything that like is kind of that boilerplate that you don't want to see. It's kind of under the hood. That kind of does it all for you. So that's pretty much it. You literally have to create your bucket, put your bucket name in here, and then Galaxy is, hopefully I have yeah, I do. Okay. Galaxy is going to upload to it. So let me minus, actually, so you can see the whole command here. I'm actually going to kick this off, and then I'm going to explain what all of it means to you, because it will take potentially like 5 minutes or so to catch up to the network. We're catching up to testnet. I'm ironically using Horizon here, but to get the latest ledger, I could start from 0, but I don't want to sit here for 4.5 days while it uploads the entire history of the network. So I'm going to just I'm going to start it at 10 ledgers ago for illustrative purposes. But this is going to take like 5 minutes to catch up to the network, so we'll have more than that in the bucket. Winding back, right? All you have to send this is your credentials file for GCP. In my case, these are private, or my personal credentials, because I learned as I was doing this last night that I don't have permissions in our Stellar org project to create service accounts. But if you're rolling this out in production, that should be service account credentials. I pass that into Galaxy, right, as a environment variable. And then I also mount that config file that I just showed you before, which literally just has this, right? That's literally it. And then I pass it the start ledger. I run this, this append command. So append, really all this means is, well, as it states, right, it's going to append. So if I were to Control-C this process right now, and let's say it had already uploaded like 20 or so ledgers, right, it's not going to like go re-upload. It's not going to overwrite those ledgers. It's just going to start from where it left off, right? So that's really probably the behavior you would expect, but you can configure it in other ways is the point. So this is going to take a hot minute. Oh, never mind, it's already uploading. Sometimes this does take a hot minute because of captive core. So captive core occasionally needs about 5 minutes to catch up to the ledger. A checkpoint, if you're not familiar, is every 64 ledgers, something called a history archive is published. This is something core publishes. It's stored in S3. If you're trying to catch up to the ledger and you are in between, or you're trying to catch up to a ledger that's not the most recent, it's after the most recent history archive was published, but the next one hasn't been published, sometimes you have to wait for that. So point is, sometimes you may have to wait up to 5 minutes, but that's a core restriction, not a Galaxy restriction. So you can see in our logs here, right, that we're uploading files. So I'm going to go over here to my bucket in GCS, and I can see that they are indeed here. This is kind of what I was describing to you in the config, which was our partitioning structure. This is really just for kind of like organizational nicety. A partition, I have it as 64 ledgers in my config, is one of these guys. And this bucket is basically going to have all the individual ledger files that were uploaded. This format may look a little bit weird to you. The file name of this, the file names here, chose 64 ledgers per partition because that's the same amount as a checkpoint. So that's what I just previously mentioned. Every history archive, every 5 minutes, core uploads a history archive. If you use a partition size of 64 ledgers, that's literally the same. That's the same as history archives, but you can have it be whatever you want. And then in my case, I've chosen 1 ledger per file, so you can see the ledger number is indicated in the file. This prefix is it's really just a hash of the start and end ledger of the file. And the only real reason, there's some extra complicated bits in there, but the only reason that exists is because we wanted this to show by default in GCP in ascending order, right? So again, they're kind of like operator niceties. GCP by default sorts in ascending, whereas you probably want the more recent ledger to show up first, right? So we're basically just finagling the interface in code so that you have a little bit nicer of an experience when you're looking at it in GCP and you want to see the latest ledger. But I'm going to leave this. I'm going to leave this running because then we're going to read from it. But just to take that in for a second, we're right now from our local computer, right, in like pretty much less than 5 minutes, we're like uploading ledgers consistently to our own bucket. And we now own that data, right? We now have that data in a raw format. It took us basically no time at all. So if you think it's going to be hard, you think it's going to be too hard to run Galaxy or Captive Core or whatever. It's really not. It's basically no work. So I'm going to look at the ingestion side of it. So I said I was advised against the live coding, but I kind of put stages of my coding here in different Git branches that we're going to walk through to kind of show you how I did it. All right. So all I've got here, is this big enough for you guys? All I've got here is pretty much nothing. I've got main.go. Now, the ingest package, this is where we're at now, right? The ingest SDK, something that's actually been around for a while, but it wasn't really broken out in a way that you could use it or marketed as much as we're doing here. But this has existed for a while, and it's in the Go monorepo. So that's the same place that Horizon lives. There is this little package here called the ingest library. And as you can see here, kind of, this is a great ASCII diagram, but kind of, we should maybe change these documents because you don't know what buffered storage is. But point is, these are the two options for how you could get data, how you could get ledger data. Captive Core, buffered storage, spoiler, is GCS, right? It's kind of the generic name for a data store, a remote data store, right? So we have in code, right, this library buffered storage backend that allows you to pull data out from GCS. That's what I'm using here. That's what I'm using here, so it's all going to be in the ingest package. I'm using a couple other niceties from the Go monorepo because I am writing in Go, but you don't necessarily need to do that. Oops. But I would advise it for some cases. So what I've done here, first and foremost, is I've defined a kind of a struct or data model for what I'm going to view as a payment, right? Because remember, what I'm trying to do is I'm trying to get Memo onto a payment and then serve it in an API. Payments are a little complicated on Stellar in that there's many. Oh, it's not the search I wanted. The schema is actually completely different depending on the type of payment. So if you see here, we have create account, all the different operation types that could be a payment. And all these schemas are completely different, which frankly sucks. Because if you're a end user and you're trying to query payments, probably just what you want to know is who's it going to, who's it coming from, and what is the asset and what is the amount, right? So what I'm also doing here, spoiler, this isn't the point of the talk, but is I'm kind of making a better version of the Horizon Payments API depending on your perspective, right? Is it a true form of what's on Ledger? No, but this is a more user-friendly version in my view. So that's what I'm going to do. I'm doing that first before I add any kind of Memo niceties to it. All I'm doing we're going to gloss over some of this for the purposes of time, but I'm happy to, this is pushed to my personal GitHub. I'm happy to talk about it in more detail later. This is basically kind of configuration setup. I'm using the SDK, the Go SDK, this function from the ingest library, which effectively is just giving me kind of like a cursor through all the ledger data, right? So I can get all that ledger data, apply a function to it. The function I'm applying is a transform function. So this is basically, everything else is kind of, I would call it setup, right? Setup of using the ingest library. And this is what I'm actually doing with it, right? So I'm very simply just creating an instance of my payment object that I just made. We will ignore this for now, but IDs, operation IDs, are not in the protocol. They are defined by a SEP, which is a Stellar Ecosystem Protocol, which is why this looks very confusing. There's a Go implementation of it, but again, I can get more into it if you're interested. not the point of this talk. But besides that, all my other data here, I pull directly from that ledger close metadata that I'm getting from the ingest library. I have the transaction entity. I can pull out the actual operation, the payment, and I get everything I want. So all I'm doing is printing it out just to kind of, at this point in stage 1, to show you that it works. This is reading from the version of Galaxy that I am running, right? So I'm pulling data not from any public source, just from the version of Galaxy that I'm running right now. Ledgers close every 5 to 6 seconds, so we'll see those stream in as we go, but oops. Nope. I'm going to go to adding the memo, the cool part of it. So recall that preamble I gave you about Horizon, why it sucks, or why it would be extremely hard to do this. In this case, actually, let me do the stat first. It's basically no additional code. It's a little, actually, it's 30 lines, it's a lot. I'll show you why that is. But all I'm doing in the transform function, I've actually pulled out this get memo function, and this is what I'm doing in the get memo function. Now, this looks a little intimidating, actually, right? You may be like, well, the memo is a field on the transaction. What's going on here? If you recall, you may not, because it looks like I never opened it. Oh, it was in my presentation, not on a tab. Memos can be multiple types, right? And what we're trying to do is actually print them out as a string. So all I'm doing here is a bunch of really annoying string manipulation, which I probably could functionalize, but that's the reason this isn't just as simple as .memo.get text, right? Because it may not be text. If you ever run into anything like that when you're parsing through, or when you're kind of trying to explore the ledger metadata yourself, you should really be looking at the docs for the SDK that you're using. So in this case, that's the Go SDK. If you're familiar with the JS SDK, I would use those docs. They're deployed as JS docs. If you're familiar with the Python SDK, right, they also have docs. So all these functions, right, are all available in the SDKs. That's all I've done. I've literally just added this function to get the memo. I'm going to run it again, and sorry, I'm going kind of fast at this part, but I'm running out of time. Boom, I got the memo. Okay, they're empty. This is a weird looking one. Let's sanity check that that's real, just for. So I'm using Horizon, ironically, to validate. But we can see here this Horizon Operations API. I just queried it for this operations. Our service just printed out. There's no memo field, of course, because it's the Operations API. But I'm basically doing now what the guy sorry, the person, I don't know if he's a guy, was doing when they filed the issue. Thank you, gosh, darn it. Which is, now I have to actually call the transactions API for the transaction that I got back in that operation. That's transactions. And here we have the memo. There it is. In this case, this is the raw memo as bytes. And this is, in fact, the memo that we got in here. Okay, so we're good. We're good. Now, we could have stopped here, and boom, we have it in code. We haven't served it via an API yet. I'm actually going to skip over one of these that I did. You see I have 3 kind of examples for demo 3. One of them, this first one, add API, does create an API in Go that then serves a payment API. But I wanted to go a step further and show you how you could actually do this in other languages. Because what you may be thinking at this point is, right, okay, great, the SDK, the ingest SDK, it exists in Go, but I hate Go. Go sucks. We've actually heard that quite a bit because some of our early adopters or some people that we want to be early adopters of CDP, they tend to be data providers, and those people tend to have expertise in Python, not in Go. So I've actually done a different strategy here where all I'm doing, instead of printing, I think I'm also still printing, so we'll see. Instead of printing, or in addition to printing, looks like I'm still printing. Let's do just main.go. I'm actually writing the data to a in-memory 0MQ queue. So this is actually an MQTT implementation that is extremely lightweight to run locally. You may think this is additional kind of like complication and infrastructure, but I also like this example because it's kind of showing you a true like ETL and putting kind of queues in the middle. So if you, instead of printing, well, I'm printing as well, but publishing to a 0MQ queue, I can now pick that up on the other side from a Python API. I could pick it up from multiple, it's multi-consumer, right? So I could pick it up from, you could do this with Kafka, right? You could do it with RabbitMQ, any MQTT implementation, anything you want. I'm unlocked, basically, right? I'm unlocked from like actually needing to write Go code, a little bit of Go code. We could maybe, you could use this example that I've written here, use this Go code to publish it to a queue and deal with it on the other side, right? So the rest of the diff here, you'll see it's pretty minimal. It's just passing that socket around that I've created for the 0MQ queue. And I'm going to create a virtual env here because what I also have added is a Python, a subscriber on the other side in Python that does literally the same thing right now. It's not an API yet. It's just printing the payment. So I'm just sanity checking at this point. Okay, I have Galaxy running over here. It's uploading ledgers. I have a Go ingest SDK that is kind of my extract phase, right? It's extracting the data for me and transforming, right? And then on the other side is going to be my like load, right? My like Python API that's going to load this. So again, all it's doing is reading from that 0MQ socket and then printing it here so we can just validate that we're not crazy. So I'm going to run that Go service again. It's going to be printing out our payments. And cool, we have it over here as well with our memo. And I'm going to leave, well, I'm not because I got to switch the branch. My next one, sorry, I wish I could have done this. This is the fun part. This is the cool part. But I'm running out of time. So I'm going to switch right over to the fourth one, which is where I'm going to actually add the API, where I have added the API. So I'm going to show you again. Oh no, what was it? Add 0MQ. So there's a bunch more stuff here. I've done a very lazy version of creating a Python API where I still have my subscriber. It's all in one directory. Again, this is a hack, so you do it nicer. I'm creating a table. I'm using SQLite, again, just for the purposes of illustration. It's a very quick and dirty example. I've created a Flask app that basically has one endpoint that is payments, and one feature, which is you can sort by ascending or descending. Again, just to kind of show, I'm trying to show the dichotomy between Horizon's API and this API. So that's literally all it does. It just saves the data that it gets off the queue, and then it actually serves it, or saves it in a database, and then it serves it via an API. Oh, indeed, you don't. So just so keeping us honest here, right, where we've got basically nothing in here. Flask brought most of these things in. Yeah, we're not implementing a WSGI server because we're just running on my local laptop. So I'm going to run that Go program again. So just to illustrate our three tabs here, we've got Galaxy uploading to this bucket. that's kind of the extracting from captive core. We've got the ingest library right now reading from captive core, transforming that data, dropping it on another queue. That's your T phase, transform phase. And then we've got a Python service that is picking it up from that queue, loading it into a database. That's your L, right? And then serving it via an API. So we got it already queued up. That's gross. But now we have an API. This is the API that we just spun up in Python, serving the exact payments model that we just came up with a memo, with an actual memo, which is, we didn't live code it, but it probably could have taken us like an hour to set up, including running Galaxy to do so, right? So what I want you to take away from this is, it sounds very complicated. It sounds a little abstract, right? Like, I don't really know, I don't know Go, right? You don't have to know Go. You can take this code that I've written now, right, and dump it onto a pipe. You may say, well, I don't even want to write this amount of Go. Like, this intimidates me. Like, what are we doing here? Fair. I've written the transform stage in Go, right? Maybe this intimidates you, right? You don't know, you're not familiar with the XDR model or the SDK models in Go. That's totally fine. Let's say, oh no, what's the Python CN? Yeah. Say Python API is your favorite. They also have XDR models, right? So you may be familiar with this if you've used the Python SDK. So if you're like, this is too much Go for me, I hate this, that's totally fine. Instead of transforming it in your Go code, dump the raw bytes of the XDR onto that queue, have Python pick that up, and now just parse it with the Python SDK, right? Or parse it with the PHP SDK or the Ruby SDK, or whatever the heck your backend language is, right? So I guess all that is to say, right, even though the ingest SDK library is only available in Go, you're not limited to that, right? As long as you have the ability to kind of, or the knowledge of how you can work with those kind of SDK, XDR models in whatever your preferred language of choice is. And yeah, that is it. Kind of sped through that, but any questions? Go ahead.
Why do you hate product managers?
John, I love you. Come on. I'm just, No, what I was really trying to emphasize, right, is us engineers, when we say it's going to take a month, it's not because we don't want to help you. We want to help you. When I see this poor soul, like, file an issue like this, I feel for him. This is a reasonable request. I would like to do this. It sounds like something that should be there. I think we at the protocol level made a complete mistake when we put memos on the transaction instead of the operation. It should have always been at the transaction or the operation level. So I feel for them, and I want to help them, but it's the trade. It's not worth it. And this is why product engineering tension exists, right? As old as time. Tale as old as time. Go ahead, Marwan. Just, I don't think that's on. Can you, I'll repeat the question, tell me if it's wrong. Can you set a max number of ledgers to ingest and then start what?
And then start evicting ledgers like past that max. So like you start with like first in, first out.
To GCS, you mean?
Yeah.
Yes, not by design right now, because the way we've assumed people will use it is they want to store the whole history of the blockchain. It's 3 terabytes right now, compressed in GCS. You could manually delete from it, but It's very cheap. It's very cheap to run, and I would actually argue that it's better to have the raw data always there. I gave this example in my talk yesterday, but I'll repeat for those of you that weren't there. Imagine a case where you're a wallet backend, and you're saving in your application database, you're filtering, you're doing this ETL, you're filtering only transactions related to accounts that you own, right, that you care about. But then your product manager comes to you 3 months later and is like, we want to add a feature to import accounts that were previously never known to us, right? And we want to be able to show their full transaction history, right? If you're reaping stuff, you're kind of screwed at that point because you don't have that history. And if you're not running Galaxy or you don't have the raw data, you would currently how you'd have to do it today is run captive core from Genesis. We could query Horizon, or run captive core from Genesis, which is going to take 3 months, right? So you're going to say, cool, you can import an account, but 3 months later, we'll be able to show your transaction history. Your product manager is kind of probably going to be like, no, that's not cool, man. So if you have the raw data, you can kind of do it real time. Request comes in, I want to import an account. I'm going to spin off like an asynchronous process that's like my backfill history for account job. It queries GCS directly and then rewrites, basically does the transform flow that you're always doing, but for that single account, right? So point is, right, like or another example could be like maybe you're writing your data to Cassandra and you screwed up your partition key, right? Like it's too big now, and you've realized you actually need to add like a truncated or a sealed timestamp field to your partition key. Well, that means you're gonna have to redo. You're basically gonna have to re-ingest, re-add all your data into your gold data layer. But you have the raw data, right? So you can do that pretty easily. The burdensome part is getting the data out of the ledger, right? It's running captive core, getting that data out of the ledger. Assuming, right, you're doing it in actually sequential order. If you're trying to do it by random access, it's impossible. You just can't do that. So I would encourage you to save it all is the TLDR, so that future you won't be as sad.
What's the GitHub for the demo code?
That's on my personal GitHub, which I will share in the in Discord in the Composable Data Platform channel. Plug for that Discord channel as well. Cool. All right, thanks guys.